All right, team, today we're discussing how wind and ocean patterns can change the weather and climate here on our Earth. So let's dive right in. First, we know that ocean currents can move heat throughout the Earth. We saw this last lesson where warm weather was carried away from the equator after it had been heated and colder water was carried toward the equator. So we can clearly see how the ocean's currents move heat around our globe. Where there is heat, there is energy. So here we have energy movement as well as heat movement. Now heat, energy, and carbon dioxide are constantly being exchanged with the atmosphere. Let me explain that a little bit further, okay? When our sun is shining on our Earth, it is giving its energy and pouring it, so to speak, into the ocean. And that is where the water gets nice and warm. Now, because it's getting warm, it's starting to evaporate. As water evaporates in our atmosphere, it condenses and then rises. And then, of course, that starts the rain. Okay, this is the water cycle. This is why it rains more in some areas around the equator than elsewhere on our planet. Okay, this is because ocean regions are warmer around the equator, and this is the big water cycle. And as this water cycle continues, the water absorbs energy from the sun. The sun's energy heats the ocean, which causes condensation, which causes it all to rise, which causes rain, so on and so forth. So, in the central region around our equator, we're going to have more what we call tropical or climate. This is where it's warmer and it's rainier than in other areas on our globe. Now, we can look at the climate on coastal regions. You'll see in this picture that the climate on the coastal regions, which is the region of land that is right by the ocean, we can see that these places are cooler than others during the summer, but warmer than others during the winter. Regions by the ocean are going to have less drastic changes in their temperature and therefore have a more moderate climate. Okay. So here we've got weather maps. Let's start our discussion on weather maps. Weather maps show us weather data. This data includes precipitation, air masses, temperature, the movement of fronts, air pressure. Weather maps are also going to include a key. Now this key tells the reader what the symbols mean. The symbols show the different types of weather fronts. Now, what is a front? A front is where two air masses meet. What is an air mass? An air mass is a large body of air with the same temperature and humidity throughout it. Now you might be thinking, what is humidity? Remember, humidity is the amount of water vapor that's in the air. Now you live in Texas, right? So you probably know what humidity is. It's that sticky feeling that we get when we go outside because there's so much moisture in the air. Okay, so if you have a high humidity, you have a high amount of water vapor in the air around you, and that's what gives it that wet, sticky feeling. So what are fronts? Take a look at these symbols here on the left side of your screen. So a front is a place where two air masses meet. The blue triangles show a cold front. The red semicircles show a warm front. The triangles that are in half circles together show an occluded front. And then we've got, this is where the cold front is traveling faster than the warm front, but in the same direction, and it eventually catches up to it, okay? And then we've got the triangles and the semicircles together, but they're on like opposite sides of the line. This is a stationary front, okay? This is when they collide, but neither one of them can overtake the other. They've become stationary. All right, so now let's look specifically at cold fronts. Cold fronts are shown at the top of your screen here. And this is what happens when a cold, dense air mass moves into an area. And then when this cold air mass bumps into a warm air mass, storms are likely to form. Strong storms are associated with cold fronts, like thunderstorms will be likely in the summer, snowstorms are likely in the winter. When a cold front passes over an area, the temperature will decrease, okay? Remember what we've learned in previous lessons. Cold fronts, gases and liquids, they're more dense. So when the cold, dense air bumps into the warm air, the less dense air will rise above it. So that warm air is going to rise above it. And that's where you see those clouds here in the picture. Thunderstorms are going to occur along this boundary line, okay? Then, what do we have about warm fronts? Well, those are those red semicircles, and this indicates a warm front moving into an area. When a warm front meets a cold front, it will slowly rise over it, okay? Heat rises, right? Less dense things rise. When this happens, sheets of gray clouds are going to form. That's this here. Okay, and it'll usually bring with it rain. You can see the warm front here going this way and it rising above the cooler, denser air. Now, where there's precipitation ahead of the warm front, you're going to see those rain and snow that follows. But this is going to be a more steady rain or steady snowfall, not the stormings that we would see in a cold front, okay? So have you ever felt that warm and sticky air? I'm sure you have because we live in Texas. So this would be that humidity, that precipitation ahead of that warm front, okay? So this will bring that steady rain and steady snow. Once that passes, the weather is decent, and usually a cold front is not far behind, okay? So remember, cold fronts bring high wind and heavy rain, and in a warm front, the temperature will rise and then it'll pass, okay? Now here we've got a stationary front. Now this is when a warm front and a cold front meet and they lock together and neither one can overtake the other. This combination of temperature and humidity will cause long periods of rain. Finally, we've got the occluded front. And these are fast-moving cold fronts. So if we've got a warm front here and a cold front, the cold front is going to move faster than the warm front, catch up to it. Okay, and then it's going to bring with it dry air. Now next we've got the different pressure systems, okay, air pressure. So what is air pressure? I'm going to start here on the right hand side where the L is, and this stands for low pressure. A low pressure system is an area of low pressure. This is a sudden drop in air pressure that usually brings stormy weather. At the surface, moist air comes together and then it rises to create stormy weather. Okay, a rise in air pressure is called a high pressure system. This is what the H stands for. In the atmosphere, the dry air will sink and then separate and create nice weather. High pressure is usually associated with nice, decent weather. I remember the H in high pressure meaning happy. I feel happy. This is happy weather. And then, of course, the L in low pressure leaves you feeling lousy. Rain clouds, not so much fun. Okay, so now we come to the more severe weather. We're talking about like cyclones and hurricanes. Now, for a hurricane to form, the region around it must meet the following 4 criteria. Okay, there's 4 things in those little boxes on your screen. First, there needs to be low to medium winds, all blowing in the same direction. Not super fast winds, low to medium winds. Okay, secondly, the winds need to be between 5 and 30 degrees latitude of the equator, okay? So not at the poles. It's got to be within 5 to 30 degrees latitude. Does that make sense? So we've got the equator. The equator is at 0 degrees. You can go 5 to 30 degrees north of it, 5 to 30 degrees south of it. That's the region where we're going to have hurricanes. If it's outside that region, it's not a hurricane, okay? Then thirdly, we've got the ocean surface temperatures, and they need to be fairly warm. They need to be between 80 degrees, like around 80 degrees Fahrenheit or 27 degrees Celsius. This is pretty warm. These warm temperatures, these warm ocean temperatures need to extend 150 feet deep into the ocean, okay? So fourth, the atmosphere must be moist. Think humidity. okay? All four of these things must be met for something to be classified as a hurricane. So on this page, you can see like what a cyclone would classify as, either a tropical depression, a tropical storm, a hurricane, or a major hurricane, depending on, of course, its wind speed, okay? In order to get one of these cyclones to weaken, one of the four factors that we just talked about need to weaken. For example, ocean surface temperatures would need to start getting colder than 80 degrees for the storm to weaken. Or a dry air would need to move in instead of having a moist, humid atmosphere to get the storm to weaken. Or the winds need to shift, or land masses would be needing to act as barriers to get the storm to weaken. All right, you guys, that was a lot for today's lesson. If you have any questions, you know where to find me. Thanks.